Okay, so this is where we're at. We've got a map with a sun, a player ship object, and then we've got these procedurally generated objects. So as I move around, it will generate these around the player ship, and it updates these every 2 seconds. Right? So if we pop into the code, this is reasonably reasonably simple. We have this procedural loader script. It has a detection range. I actually upped that to 20 in the game. We've got a game object pointer to player. We've got a list of planets. Well, a list of game objects called planet. So we're setting up our list, and then we're starting this run coroutine. So the run coroutine basically just loops, and every 2 seconds updates the map. Updates the map, waits 2 seconds, updates the map, waits 2 seconds. That could probably actually be a little bit closer together. So then we've got this update map function, and what this does at the moment is it's based on the player's polar position from the sun, and I'm using my my 2 polar free extension on vector freeze to get that, calling the generate function. Eventually this will have other information as well. So our generate function takes in that polar free position. First thing it does is generates a random seed, and this random seed at the moment, this is not a great way of doing it, but is generated by adding the angle, the elevation and the radius and converting them to an int. And then we're setting the random number generator seed to seed. Now what would be really great actually, on a quick aside here, is that sometimes I want an instance of random, and I don't think you can do hang on. I don't think you can do this. I don't think you can say random and equals new random. Right, I don't think you can do that, can you? Yeah, so you can't, unlike the one that's built into the system library, like the standard .NET system library, the Unity one doesn't have, it's like a static or a singleton based random number generator. I don't know why that is, which is problematic, I think, because there's cases where I want to use it here, but say in combat, in multiplayer, I'd want to sync up 2 instances of random number generators together with the seeds on each player's computer, and then do the dice roll that way, I think. I don't know. Anyway, so we're setting up the random number, and we're setting the seed, and this sets it based on this. We're then calculating a number between 1 and 10, because I just pulled 10 out my arse there. This sort of stuff, like object count, object size, that sort of thing, will all be based on some sort of curve, like a probability curve. So in the case of object size or object mass, or whatever you want to call it, asteroids in real life follow quite a strong, like, kind of logarithmic curve of size. So you get the vast majority of them are very small, and then some of them are very big. And that, I've got that curve somewhere in a bit of code, and I played around with that, and it works quite nicely. So all of these things are going to be generated. The object count will be generated either by a curve, or possibly by loading in some data that says this far from the sun, expect this many things. This far from the parent, from the planet you're orbiting, expect this. Expect a ring of this density. So this is going to get more complicated. So, but for the moment, we're just generating a random number between 1 and 10 based on that seed. We're then going through and we're creating an object name, and as you saw in the demo, the object's names are the seed and the number that the object number from this. So this basically gives us like a unique object name generated from this seed. And then what it does is it goes through planet, and it uses this, I can't remember what these are called, lambda expression. Use this lambda expression to count the number of objects in this planets collection with the name, object name that we've just got here. And if it's greater than 0, so it already exists in that collection, don't want to do this, so we call continue here, which runs round, increments I, and does this again. So if it wasn't greater than 0, so it's not currently, an object of this name isn't currently in the list, then we want to actually generate an object. So we're getting this object position, and we're generating that by getting a position inside the unit sphere, which gives you a unit vector, a random unit vector inside a sphere. So its magnitude is 1, and then we multiply that by the detection range. Sorry, no, inside unit sphere gets you a vector, a random vector 3, which has a maximum magnitude of 1, but it could have any magnitude. Yeah. And then we're multiplying it by detection range to sort of spread them out a bit. We're then generating a new primitive cube, calling it object. We're setting the position to the position of the player plus this offset, so it will instantiate it near the player. We are then adding it to the list of planets. Sorry, brain wandered off for a second there. And then doing a little log message. So that basically generates all of our procedural objects as this updates. Then there's a clear method, and this is a useful trick if you don't know it. You can't delete something during a for each loop, because you then delete the thing, you change the collection that you're looping over, and you can't do that. So what you can do is, if you create a temporary collection called toClear, well, whatever you like really, but I always call it toClear, you go through, you check whether you want to remove something, and in this case my criteria for removing is the distance the player is away from the object greater than the detection range. So has the player moved outside of the detection range for this object? And if it has, we then want to add the object to this toClear, right? So then as soon as we exit this for each loop, we're now free to modify the planets, the one that we just looped over, right? Because we're no longer looping over it, it's now free to be changed, so we can remove and add things. So then what we're going to do is we're going to go through the toClear collection that we just created, and then we're going to remove the objects from the planets collection, and then we're going to destroy the object, right? And then at the end of this function, this temporary thing gets cleared up by the garbage collector. So all of the objects in here get deleted, which makes sure that everything is gone by the time we exit this clear function. So that's quite a useful thing. I found that out a while ago, and it was really useful to know. Because I had a bit of code where I just wanted to delete something. This is years and years ago. I wanted to delete something from a collection while looping over the collection, and obviously you can't do that because you're modifying the collection you're iterating over, and basically the C# runtime just can't deal with that. Yeah, so that's where we're at. If I run this again, you can see that regardless of which direction the player moves in, we are going to be generating new objects for the player to play with. So, my thoughts on this. Obviously, generating these objects, setting up the orbits for these objects. I'm going to start with circular orbits because they're easier. The inclination is going to be based on the player's height above or the object's height above the plane. So where the player is, they'll always be at the highest point on their orbit above the plane of the solar system. So that's what I'm going to do next. That's not obviously a particularly good way of doing it, because that's going to look a little bit weird, where wherever you are, you're always meeting things. They're always like kind of going around in a similar plane, and you're always meeting them at the highest point, at their kind of their apoapse or the periapse, as it were. So that's my next step. I'll probably do that in another video, so I'm going to stop recording this now and quickly edit it to do all the fast forward stuff. And in the next video, I'm gonna go through and get these things generating orbits, and then it will be culling things based on whether you're near them in the orbit. Awesome. Okay, thanks for watching, guys, and I'll see you in the next video. Rock on.